Alright, so now we're at the point where we want to solder a little prototype board here. So we got a couple chip holders on, then we're going to add some terminal blocks, the voltage regulator, and a bunch of these wires to go across. Usually you just follow this little piece of paper here. It'll tell you, wire 17 goes to wire 3 of the wire 17 of the Atmega goes to wire 3 of the H-bridge. So it makes things fairly simple. And you can have a picture too, but I found that it just works out pretty good to have the drawings from number to number. Just as a quick status update here. So we have the two chip holders hooked up. This will have the Arduino chip and this will have the H-bridge for controlling the stepper motor. And then we got our inherent capacitors here. Those help to smooth any voltage transitions, or if there's any inductive loads like on the stepper motor, it'll smooth out those voltages. And the two terminal blocks here, this is where the 12 volts come in. And then this voltage regulator steps the 12 volts down to 5 volts. And then the 5 volts can power the microchip here. So what we have left is to connect the wires from the Arduino chip to the H-bridge. And then we got 4 wires that'll come off to a connector on this H-bridge. And then that'll ultimately connect up to the stepper motor. And then there's 2 resistors and a diode that we need to hook up to this for the solar input. And then we'll probably maybe hook up another one of these terminal blocks for the solar input, or just solder a wire on here and output it and then figure out a way to connect it later. So yeah, that's currently the status. It's a pretty long process. Most of the time this stuff is just all on a printed circuit board. As you can see, it is very time consuming, which is why people generally elect to create a circuit board. Once you create a circuit board though, then you're kind of married to it though, so this is kind of nice because we can mix and match with everything. Like for example, while soldering, I decided to have this big capacitor, realizing with the stepper motors, probably I'll need one. But every once in a while, stuff like that falls through the cracks when you get into the designing phase. Once you get your hands on the stuff and your brain starts to work a little faster, then it's a little easier to come up with different ideas. So we go ahead and solder up the wires to connect the Arduino chip to the H-bridge chip, and then a couple more wires and we should be good to go. Alright, so we're pretty much completed with the soldering. We just have to check this all over, make sure we didn't forget anything. Which usually happens given a project of this magnitude. So solder up some of these pins that were lost but not forgotten. And then once we get that done, then we'll want to clip off all these leads here, just so they don't short circuit on other circuits. And then we should be good. And the only thing we have after that is we're going to put these 4 wires into a connector. And this is what connects the stepper motor with the H-bridge. So, you know, this whole circuit will be inside a box, and then a connector will come in and it'll connect this, and then it'll connect up to the 12 volts. So from the outside, we're going to get a 12 volt input, and then a stepper motor output, and then we'll get the solar panel to come in too. And that'll come in on one of these pins on here. So we'll get that all done in a little bit here, and we'll be right back.